Alright, let's talk about the SimpleGrid for CS 141. Woohoo! So some learning goals. SimpleGrid. It's a new variable type. We're going to talk about what the methods are for it, and then we'll look at ways of combining for loops with the SimpleGrid. This is a totally awesome thing to do. It's actually very, very powerful. It allows us to do quite sophisticated things without a lot of code. So SimpleGrid is a type. It's a new type just like int, double, and string. But to create a simple grid, it actually requires a little bit more work than to create a new int, double, or string. This is the syntax here. SimpleGrid g equals new SimpleGrid, and then some parameters. The left-hand side of the equal sign, this is the variable declaration. So SimpleGrid g is kind of like int x or double d or string s. The right-hand side is what's called a constructor invocation. We'll talk more about constructors quite a lot as the term continues. So let's do a quick intro into this idea of a constructor. We will cover this in considerably more detail. The idea here, new SimpleGrid 4,6. Well, new is a built-in keyword for Java. It's sort of like int, double, static. It has a special meaning. You couldn't name a variable new because the word new already has a specific meaning in Java. SimpleGrid, this actually has to match the name of the type. So the constructor for SimpleGrid has to be called SimpleGrid. Now the 4, this indicates the number of rows you want in the grid, and 6 indicates the number of columns that you want in the grid. So we're saying that it's 4 squares tall, 4 rows, and 6 squares wide, 6 columns. 6 times 4 is going to give you 24 total squares in this grid. SimpleGrid actually has a second constructor. There's 2 of them. The first one you have to specify rows and columns. This constructor, you just specify a single number and it will assume that the grid you would like is square. So if we say new SimpleGrid 5, this assumes that you want the grid to be 5 by 5 and will respond accordingly. Now what can you do with a SimpleGrid? Well, you can set colors. So we can create a simple grid. We're going to call it G. Again, this is just a variable declaration over here. You can name this variable anything you want. I'm calling it G or grid in these examples, but you could name it, I don't know, whatever you'd like. So when we say set color 2, 3, color.red, we're saying that in row 2, column 3, I'd like you to make that square red. Set color is what's called a method. These values here are what are called parameters. Some methods actually need 0 parameters, but most methods are going to need 1 or more parameters. Parameters are a way that you pass information to a method. If I just say g.setColor and I don't give any of these parameters, well, one might ask, what row, what column, and what color would you like me to set? If I just say set color, well, set what square to what color. Without these parameters, like, oh my gosh, that's terrible. I need to go switch the laundry, but I'll finish this video first. Sorry, that was very unprofessional. Okay, so set color is able to set the color of a particular row and column to a particular color. Now you might be asking, color.red, what the heck is up with that? Well, color is actually a built-in thing that's provided by Java, which we'll look at in a little bit of detail, but we don't really need to mess with it too much. It's built in. I'll show you how to use it. We don't really need to worry about how it's implemented. That's beyond the scope of this particular course, this particular example. So now I'm going to demo the SimpleGrid, show you a couple of things that it does. One thing to remember about simple grids, and really about anything else as computer science, we start counting at 0 instead of 1. So the first row of the SimpleGrid is not row 1, it's row 0. And the first column is not column 1, it's column 0. I also need to remember to show you how to import both SimpleGrid and color. So let's go over here to BlueJ. I'm going to minimize this. Grid test 1. Here we go. Now you'll note up here, I'm importing gridlib.simplegrid. Gridlib is what's called a package. SimpleGrid is the name of the class that we'd like to import. We're going to use a number of imports over the course of this term in 141. We don't really need to memorize any of this. You're welcome to copy-paste this from other examples. It's never going to be on an exam to remember what the import statement is. The one thing I would like you to be able to do is, if this import statement is left off for some reason, I would like you to know what the error message is when it generates. In other words, I would like you to be able to look at the error message and realize, aha, I've forgotten to import this. So let's look at what we've got here. We've got grid test 1. We've got a main method. We're creating this simple grid. We're going to call it grid 1. We're making it 4 by 6 just like in the slides. I'm going to go ahead and make sure this is compiled. Now I'm going to go ahead and run it. Let's see what happens. Dun, 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 dun. 4 rows, 6 columns. It's a simple grid. It's 4 by 6. We haven't told it to set any colors, so it's not doing a heck of a lot yet. We've just got kind of the blank grid here. So I'm going to close that and show you, well, actually I'm going to open up the code again. Now I'm going to show you what happens if we leave off this import statement. This process, I've mentioned this in other places, but I'll mention it again, of sticking a slash in front of a line. It's called commenting out. What I've done is I have temporarily deactivated this line. The text is still there, but with the slash in front of it, it's now a comment, so the compiler's going to skip over it. So I'm going to go ahead and try to compile this. Cannot find symbol, class SimpleGrid. If you forget to import something and you get this error message, you need to be able to fix it. So there's not going to be exam questions saying, hey, what's the right import statement here? But as you're programming, you're eventually going to forget an import statement and get an error message like this, and you're going to need to know how to fix it. In general, anytime you get cannot find symbol, class, whatever, that means that you spelled the class name wrong. So if I spelled this, SimpleGrid, I'd get the same kind of error message. So that's one possibility. Another possibility is I got the case wrong. I need to have the S capitalized and the G capitalized. Sometimes I might forget that and get that wrong. Or I forgot to import it. So spelling, capitalization, or imports. If you get this message, cannot find symbol, class, whatever, it's almost certainly one of those things. With string, if you get cannot find symbol, class, string, check to make sure that it's capitalized. String has to be capitalized, and so on. So I go ahead. Now I hit compile. I'm hitting Apple K on my Mac. I think it's Control K to compile under Windows. So this is working. But remember, if I spell this wrong, so I'm not doing the capitalization right, I'll get that message. I'm going to go in here and make sure that this is SimpleGrid. This works now. Maybe I don't know how to spell simple. I think there's 17 P's in simple. I'm going to get the same error message. So you forget to import something, either it's spelled wrong, or the capitalization's wrong, or you forgot to import it. That's like probably 90% of problems with this particular error, the particular error message we had before, cannot find symbol, class, whatever. Let's see. Oh, I think there was one other thing I wanted to show you over here. One other example. Grid test 2. Here we go. So here we've got a main method. We've got our SimpleGrid G. I've put 5 in here. That's going to make the SimpleGrid 5 by 5. And I'm saying G.setColor 2, 3 to red. Let's make sure this compiles. It does. Now you'll note, here I'm doing color.red. I'm also importing java.awt.color. AWT is usually pronounced AUT. It's actually an acronym. It stands for Abstract Windowing Toolkit. It's basically the first graphical stuff that came out with probably Java 1.0 or 1.1. We're up to Java 1.8 now, Java 8. 1.9, Java 9 is being worked on actively. So this goes back to the old days of Java, back in the 90s. So let's see what this does if we go ahead and run this. Grid test 2. We're going to execute this. Ha-ha! So we said set row 2, 0, 1, 2, column 3, 0, 1, 2, 3 to red. So we went ahead and set that here with our SimpleGrid. I'm going to go ahead and close that. Now, color.red, you can probably guess that if color.red exists, color.blue should also exist. Let's try that. Does that exist? Yes, it does. That'll work. All of the basic colors will work in this way. Red, blue, green, yellow. I don't know. Orange probably exists, the primary and secondary colors. Yeah, that compiles. How about purple? Does that work? Apparently purple doesn't work. So purple doesn't exist in this way. How about fuchsia? Is that a color? I don't even know how to spell fuchsia. Fuschia? No, well, either I can't spell fuchsia or it doesn't exist. Primary and secondary colors definitely work. Black, white. There are other ways to specify more specific colors using red, green, and blue values. We'll use that for the image filter assignment in a couple of weeks. For now, this will work pretty well. We're only using basic colors: red, green, blue, yellow, black, green, and so on. Okay, back to here. One question: how do we know what methods are available for a particular type? Well, for SimpleGrid, I'll tell you. There's only 3 methods plus the constructors. But for many other classes, I'm not going to be able to tell you because there's thousands of Java classes. Java comes with at least hundreds, if not thousands, of classes, and there are many libraries available online that have thousands of additional classes. So there's many, 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 many available classes to Java, and you can always write your own. You can always write more if you need a class to do a particular thing. So how do we know what methods are available? Well, there's a standard way of documenting methods called, conveniently, JavaDoc. And it's going to look, there's different formats of JavaDoc, but they all share some basic attributes. It's going to look something like this. So up here it's telling us the gridlib package has in it something called SimpleGrid. This is telling us it extends from object. We'll talk more about that at the end of the term and in CS 142. We've got a list of the constructors. Fantastic. We've got the one that just takes a number of rows, and then the number of columns will be the same. We've got one where you can set rows and columns. And we've got 3 methods. Get number of columns, which gives us back an int. Get number of rows, which also gives us back an int. And set color, where we give it a row, a column, and a color. And it actually doesn't give us back anything. It just does that. So again, these are our constructors. This is for creating a new SimpleGrid. And then for doing things with the SimpleGrid, these are the methods. So you can go look at really any class in Java and look at its constructors and look at all of its methods. And this is rather interesting. It tells you what type the method returns. So if I tell a SimpleGrid, get me the number of columns, it gives me back an int. Similarly, if I tell it to set a color, it doesn't give me back anything. Void basically means nothing. It also tells us what the parameters are. Now, the documentation, the JavaDoc, sometimes this is called the API, the Application Programmer Interface, or Application Program Interface, doesn't actually tell us what each method does. If you click on this, well, you can't click on it here, but if you were to go to the web page and click on this, it would link to probably a slightly richer description of this, but it doesn't have all of the code in there. The reason being, if the method has a good name, by looking at the name of the method, the little bit of documentation, the parameters, and the return type, you can get a pretty good idea of what that method is supposed to do. And that's really all you need as a programmer. You don't need to know every detail of how getNumColumns and getNumRows and setColor works. All you really need to know is enough detail to figure out how the method's supposed to work. This process actually has a term in psychology. It's called chunking. Taking a big problem and dividing it up into smaller problems, and then putting those smaller problems to the side into a chunk and saying, well, I don't understand all the details of this chunk, but broadly speaking, I know what it's supposed to do. So moving on. SimpleGrid methods. I'll just sort of list things in this format for future classes that we learn about over the course of the term. I'll give a column for the return types, and then I'll give you the name of the method and then whatever the parameters are. So this one only has the 3 methods plus the 2 constructors. Now, one thing to note is that methods in Java require an instance. So I can't just say, set color 2, 3, red, without saying what grid I want to set the color to. This is actually very important because you might have multiple instances of the same type, and when I want to do a set color, I need to say which instance I want to get that applied to. The standard syntax for this, for calling methods, requires a dot. So you put the name of the instance to the left, then a dot, and then the method and parameters. It's going to look something like this. Imagine this situation. We create 2 simple grids, grid 1 and grid 2. They're both 10 by 10. Now grid 1, we set row 0, column 0 to red, and grid 2, we set row 5, column 5 to blue. Now what's this going to do? Well, funny you should ask, I happen to have this example 2 grids. So if we look at this, we've got our import statements. That looks great. We've got our main. We've got exactly that code. We've got grid 1. We've got grid 2. Now, you note down here, we're saying, I would like you to do this particular set color operation to grid 1 and this particular set color operation to grid 2. Let's see what this actually does if we run it. Okay, now check it out. We have 2 grids. We told one of the grids to do a set color 0, 0 to red. The other grid, we said do 5, 5 to blue. And so we get this difference. We've done something to one grid, we've done something to another. Now, this tells you why we need to have an instance to the left here. We might have multiple simple grids, and I need to know which one I want to do this set color to and which one I want to do this set color to. This is an error pattern that shows up a lot of times with introductory students. Students will want to do a set color, and they're always working with one grid in their code, and so they'll kind of like leave this part off and just say, well, set color, well, I've only got one grid. Well, Java doesn't know that, and furthermore, you can't guarantee that forever there'll only ever be one grid. And so we got to actually list this here. I'd like to show you the error message that you'll sometimes get in this situation. If you just sort of invoke a method and it needs an instance, but you don't have the instance, you might get something like cannot find symbol, method, whatever. Now, that doesn't literally mean that Java can't find the symbol. I mean, it knows about this symbol. It's just that this symbol needs to be attached to, in this case, grid 1 or grid 2 in order for this to compile. Fantastic. Okay. Methods operate on a particular instance. Let's try this. So, combining simple grids with for loops. So we're going to run this little bit of code. We're going to create a 10 by 10 simple grid. We're going to run this loop. What's this going to produce? Pop on over to Moodle and try this out. Hopefully you came up with A, because A is what it's going to do. Now, if you look at this, we've got a for loop. We're saying int I starts out at 0, I strictly less than 10, I++, and we're doing grid.setColor, I, 0. Well, this statement here, this grid.setColor, it happens once for every iteration of this loop. I starts out at 0, and it goes up to, but not including 10, which means I is going to go 0 to 9. Well, there's 10 values from 0 to 9, and for each one of these, we're saying, do a set color with the current value of I as the row, and 0 as the column, blue. So this means that the row keeps changing. First the row is 0 when I is 0, the row is 1 when I is 1, and so on. Column is always fixed at 0, and then we've got color.blue. So this is what we're going to get. So we've been able to draw a line on our simple grid using a for loop. This is totally fantastic because we're taking what we know about classes, about methods for this very simple grid that only has 3 methods plus some constructors. We're combining it with for loops. We're starting to get some interesting patterns. Cool stuff. Oh, let's get a little trickier. Let's try to draw a diagonal line on a 10 by 10 simple grid. Bam. Which one of these? I'll wait while you pop on over to Moodle and try to answer this, or none of the above, which would be E. Do-do-do-do-do. Do-do-do-do-do. Turns out there's 2 correct answers. Sometimes I like to do that just to kind of be tricky here. So A works, and it turns out that C also works, although for slightly different reasons. So if we look at A, what we're saying is, we know the grid is 10 by 10. I want I to go from 0 up to but not including 10, so 0 to 9. We're going to do a set color I, I. This means the first one's 0, 0. The second one is 1, 1. The third one is 2, 2. And so on all the way up to 9, 9. So that's definitely going to work. Now, down here, this actually does the same thing, believe it or not. We're starting I out at g.getNumRows minus 1, and we're doing while i's greater than or equal to 0, I minus minus. Well, getNumRows is going to be 10. 10 minus 1 is 9. So we're starting at 9. Each time we're subtracting 1, we're going greater than or equal to 0. So this goes 0, 1, 2, 3, dot, 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 up to 9. This goes 9, 8, 7, 6, dot, 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 down to 0. So these actually do the same thing, but in a different order, but they have the same result. This one, this is just 0, I. This is actually going to color the row 0 blue all the way across, so each column of row 0. This one here, this is actually going to be an error, because we're trying to start here at g.getNumRows. Well, we can't start at g.getNumRows. That's 10. We only have rows 0 through 9. This one's actually, believe it or not, going to crash. And so I want to go ahead and show you, for this one D here, what this might look like, so you kind of have an idea what to expect from these sorts of error messages. So here's diagonal lines. We're starting at 0. We're going strictly less than g.getNumRows for something that's 10 by 10. This will give us a diagonal line. But imagine, instead of less than, we made an error here. We made this less than equal. So now it's going to go 0 up to and including 10. And remember, a simple grid of size 10, that's 10 by 10, that only goes 0 to 9. This is illegal. It's going to try to get up to here, but that's not a legal value. Now, is this going to crash, or is it going to not compile? Well, let's see if it compiles. Turns out it compiles, but let's run it and see what happens. Bam! Look at that. It drew everything, so this part worked, but then it gave us a little bing, and if we look at this Java Lang index out of bounds exception, row 10 is out of bounds, min row value is 0, max row value is 9 in gridlib.drawingGrid. DrawingGrid is actually the code that SimpleGrid is based on. So we're getting this error message. We're trying to do row 10, but the rows only go from 0 to 9, so that doesn't work. And then if we look here, this is the terminal window. We can see that we've got the full text of this error message here. So our code, if we actually click on this, it'll highlight the line in our code that's failing. And then if we follow this up, this is called a stack trace. It's calling into SimpleGrid, it's calling into DrawingGrid. This part we can't really do very much with because we didn't write this code. Well, I wrote this code. You didn't write this code. So, you know, you're not expected to go in and like muck around with my code. The error's actually here, the first line of code that we wrote because we put this error in it. It works for the first 9, 0 to 9, but once we get to 10, then it actually fails because there's no column 10 and no row 10. It's asking for the grid square here, but there is no grid square here, hence it fails. So it actually draws the right thing, but then crashes. Okay, so back over to here. Fantastic. Now, one thing we'd like to do whenever possible is write code that works in general. So if you note, this example here, we've got our for loop. We've stuck 10 in here because for this particular example, the grid is 10 by 10. Now, of course, the problem with this, what if we change that grid? Instead of 10 by 10, we make it, 50 by 50 or 100 by 100. To fix that, we have these methods, getNumRows and getNumColumns, which give us the current number of rows and columns in the grid. So if we have a whole bunch of code doing a whole bunch of loops with a grid, and then we go ahead and change the size of the grid, if we're writing all of our code in terms of getNumRows and getNumColumns, when you change the size of the grid, the code doesn't need to change because however big the grid is, getNumRows and getNumColumns is going to tell you. So this is actually a very big advantage over this previous approach going back a slide where we hard-coded all these values in here. If we write code that has 100 different loops, each one with a 10 in here, then we change the size of the grid, we have to make 100 different changes. Whereas here, we would just change the size of the grid, all the code would work exactly the way it did before. Isn't that awesome? Yes, of course it's awesome. So the next thing we'd like to do, we'd like to color the entire grid. Every row, every column, we want to color the whole thing. Well, this is actually slightly bad. I said red, and then all the examples here are blue. But whatever. We want to color the whole grid one color. What code here is actually going to do that? Or all of it, or none of it? Pop on over to Moodle and try this out. Hopefully you came up with A. Here's what's happening. We've got our loops J and I. J, we're doing less than, strictly less than the number of columns. I, we're doing strictly less than the number of rows. So remember, columns go first. Columns go second. Rows go first. I is the rows, J is the columns, and then we're making everything blue. Now this is a nested loop. So what this means is that the outer for loop here, J is going from 0 up to number of columns. And then for each column, we're actually going through every row and then doing the set color. So if the number of columns is, 10 and the number of rows is 6, this statement actually gets executed 60 times. So we'd do 0, 0, 0, 1, 0, 2, and so on up to 0, 5. The inner loop would end. We'd hit the bottom of the loop, come up here. J would go to 1. Now we're doing the same thing, but we've moved ourselves ahead to the next column. This isn't going to work. All this is going to do is draw the diagonal, because it's only one loop. We're setting I equal to j. We're basically drawing the diagonal. This doesn't work, because if you note, we're doing C here for the columns, R here for the rows. I'm using more descriptive variable names here to make it clearer so you can see what's wrong. When we do the set color, we're putting the column first, then the row, instead of R, C. So what will happen is, if this is a square grid, it'll be okay. If it's a rectangular grid, it's actually going to crash, which is not what we want. So I wanted to go ahead and highlight this. Row and column are switched here, so that's actually not going to work. So again, to color the whole grid blue, we've got our outer loop here. This is for the columns. We've got our inner loop here. This is for the rows. We've got row, we've got column, everything's blue. Bam! So you think of it, I is counting out rows, J is counting out columns, coordinate pairs counting everything out in the grid. Fantastic. So here's another question. How do we draw a dashed blue line at the top of the grid? So we want to write a code that'll draw a dashed line at the top of the grid, and not just on top of this 10 by 10 grid, but on top of any grid that we give to that code. Which of these is going to work? I'll let you pop on over to Moodle and give this one a try. And the answer is this one, D. So we're starting at column 0, we're going strictly less than the number of columns, but instead of doing I++, we're actually doing I plus equals 2. And then we're keeping the row set at 0, and then the column is I. So initially, it's going to be 0, 0, then it's going to be 0, 2. So we're skipping 0, 1. Then it's going to be 0, 4. So we're skipping 0, 3, and so on. If we go back 2 slides, this is 0, 0, row 0, column 0. This is 0, 2, row 0, column 0, 1, 2, and so on. So that is what we are getting here. Now, this is what the full code would look like. Remember, the only change we're making is we're doing I plus equal 2. So the new I is equal to the old I plus 2. So we're sort of bumping along every other one. Now, what if we want to start the dashed line instead of in the first column, column 0? What if we want to start the second column, column number 1? What would we do there? Well, I'll give you another shot at this, and we'll see what happens. It turns out this one is going to be B. So we still want to do every other one, so this stays the same. The difference here, instead of starting I equals 0, we'll start I equal 1. We'll change the initializer, so that instead of starting at 0, we start at 1. Right, so going back 2 slides, instead of initializing I to 0, starting in column 0, we initialize I to 1, we start in column 1. That gets us this dashed line pattern. Isn't that fantastic? God, that's totally awesome. And so once again, change the initializer. So to get different patterns in your code with a simple grid using for loops, there's a lot of different tricks you can use, a lot of different things you can do. You can use nested loops, but you can also do things if you only want to do a single column or a single row or a single diagonal with a single loop, but you want slightly different patterns. You can change where you start, and you can change whether it's every grid square, every other grid square, and so on. Cool. Well, thank you very much for listening, and we'll talk again soon.